Hello, welcome to my channel, Welding Tips and Demonstrations. Now we've got a couple of interesting things on the table today to repair in aluminium. I promised I would get something in, just in case the taxman's watching. They are freebies and they're not charged out. Thought I'd get that out of the way first. Now we've got a motorcycle part, footrest, and it has broken off in the usual suspect place. Where the bolt goes through. There's not a lot left to it, so as we're going to put the grinder on it to see what it's like and touch it with a welder. If it welds, it welds. If it don't, it don't. So I'm going to go through that and how we're going to repair that. Now the other thing is quite an interesting thing, which you never have thought, was a chap who I know, Glenn the Glass, bless him, 70 years of age, still at it. He does all the window screens and everything for plant, and he's gave me these two tubes. Now the tubes are coated in something what's going to be nasty. What the problem is, the ends on the tubes are some sort of aluminium, don't know what it is yet. I hope it's a bit of a cast and it's weldable, and he's asked me to tack it to stop it twisting because it's causing all sorts of problems. Now he's given me two, so there'll be some more to do. I'll probably get a beer off him if I'm lucky, but I'm going to show you how we're going to go about doing this, if it works or not. If it works, it's going to be a bonus for Glenn, and it's just interesting. Now he's asked me to weld it at the actual back onto the tube, which I have declined. That I'm not going to do it that way, but I'm going to show you how I'm going to do it. So these now are going into the shop. Let's get cracking and see where we go. Okay, so as we're going to go through a few settings on the TIG set. First of all, you want the AC setting on there. The arc force, that only applies to stick welding as far as I know. Right, your post flow gas is the gas after when it's quite good if you set it so as when you come off the trigger, the arc ends and then you get the gas, and the gas can go from like so many seconds. The longer you turn the knob, the longer it stops on. Now I use it sort of midway ish, quarter of the way around, which it aids cooling. As soon as you're finished, you can just let the gas cool the weld on there. So that is my go-to setting on there. So we've got the base current. Now the base current, I'll start off on the thicker stuff, which will start off on around about 80 amps to see where we go with that. Then we can adjust it. Now I always set the pulse current the same as the base current. Now the pulse current will adjust your pulse cycles. Not sure how to explain that in layman's terms, but you can mess about with that. That's something you can experiment, and you will find if you turn it right up, it'll just blow a hole in the plate. So rule of thumb, keep them both the same. Then what we've got then is your AC balance, right? Now your AC balance is like a cleaning thing. The more you put on, the more it... So it's like an oxidizing thing for cleaning the weld. Usually as a go-to figure, I can set that halfway. Now you've got your AC frequency as well, which is like your control of arc and your travel speed, basically, which that gives like a strobe. Well, it's an irritating noise, to be quite honest with you, but you can experiment with it. My go-to is halfway settings on that. Then you got your pulse width. Now pulse width is like, it's quite hard to explain. It's like you've got, like, it comes up and it goes over and comes down, and it gives you a longer goes over and down in layman's terms. That really is an experimental thing. It's like a welder preference thing, or depends what you're doing. Now it's good to fiddle about with that, to be quite honest with you. You got your upslope and your downslope. I just keep them down. Upslope, basically, it starts off on low amperage, and then once it gets up to what you've set it at, it will start. So it's like a soft start, basically. You can set that right over, so it's you can start it on very low amperage for a while, and then your down slope is the same. As soon as you come off the trigger, it'll fade down. I usually, as a rule of thumb, just keep them off, just basic to get you going. And then there's the pulse frequency. Now, if you ever hear aluminium, you can hear it. The more you turn that up, the more pulse you will get. So as until it's on full wrap, it's like a machine gun, and then it'll just pulse really low. Don't. Now, pulse frequency, I've set that before. So as you get your dimes, you can set it so as basically you can get your appearance of weld with that. And it's an experimental thing, that is, as a go-to. Pulse frequency, I'm usually up on 1, 2, 3, on round about number 4 on this Artex set. This is just the go-to settings. It'll get you going, basically. Obviously, you want the latch on 2T. That basically says once you come off the trigger, it's dead. If you put it on 4T, you press the trigger once, you don't need to press it again. It's ideal if you're doing some awkward jobs and you just need to move your hands away from the button. I have used it, but very rarely, so I always stick that on your 2T. Now, these are just go-to settings. So what I'm going to do now is weld this bike thing, footrest peg, but what you've got to realise now, it's not all about the welding, it's about preparation as well. So let's go and have a look to see how we're going to prep this. Right then, so I've got a selection of tools here which I'm going to use. Now these are quite handy. These are layer die grinders. As with aluminium, it's a very soft metal, so some people, they use fine and wonder why they get clogged up on the debarrers. These are specially designed for aluminium. Now, if you want to know a great company where you can buy them from, it's a company called VersaDrive. And if you have a word with Piers, I'm sure if you mention my name, he'll give you some sort of a discount. I've trialled these for him and they are absolutely fantastic. Some people use like a lubrication while grinding. Well, it's not actually grinding, it's cutting, because it's soft material. They use like a talon or something like that. To me, that is, you've got to clean everything up with it. I usually do these dry, which it polishes them up really nice. Now, you can't fault them. VersaDrive, talk to Piers. I'm sure he'll give you a discount if you mention my name. I'm not getting paid for this, by the way. Right, so we've got these 3 go-to tools. One's a little air sander, which I can fit like a multitude of discs on there. That will clean it up. What I'm determining first is the hole diameter, because we're going to fill it in. This is if it welds anyway. We're going to fill this in. So what we need to do is keep it nice and level. So what's going to happen when we weld, it's going to pull. You don't want that to pull. So what I'm going to do on this, I shall probably find some sort of a plate and strap it down, clamp it down to the plate. Now also, what you've got to realise as well, whatever you're strapping it down to, the heat dissipation is going into that plate. So as you think I've set this at 80 amps now, it's going to pull it all away from there. So as I might have to up the amperage to actually weld it. So what I'm going to try and find is something a little bit thinner, but we'll hold it straight. So we'll clamp it, but we're going to try and access the sides. So as I can grind this fully out, both sides, then we'll put the weld in while it's in that position, and then it's not going to go anywhere then. So as the object today is to clean all this hole out and totally fill it in with aluminium, ready for the customer, or I might drill it myself, because I'm feeling quite happy today. So as I'm going to do that, so what I'm going to do is I'm just going to prep all this up now, and I'm going to show you how we can get it in that position, ready for filling in and cleaned out. As you can see, we've made a multitude of clamps to to get it nice and level and ready with a prep. So as we can fill that in, then we can grind it out from the inside. It's useful to have a few heavy blocks lying around as well on your bench. That's all now nice and in line, and let's see if it'll weld. So as we've got a nice weld in there, you can just about see it. So that should obviously be good. The one thing that it's not a crap cast alloy, so it's welding half decent, to be quite honest with you. Let's get the other side done. We knocked the amps up to about 97. There's quite a bit of heat in there, so it's gone in quite good. So we're just going to pull the clamps off here now. We managed to find like a little bit of a bar to hold it straight. As you can see, that's nice and straight now. Now I am just holding this with the tip of my fingers. It's getting quite hot now. So as the transfer of heat in aluminium is you know, extremely fast, not as fast as brass, but like you can see now where we've gone there. Now what we're going to do now, let me just put that down because it's getting too hot for my pinkies. As you can see now, let me just see if I can find something with a pointer because of my fat fingers. You can see now where it's penetrated through both sides. So I'm going to put this in the vise now. We're going to clean all the inside out and put a bit of a fillet in there. First of all, I think I'm going to grind that lot out, fill that in first from the back. Just get that in the vise and then dig into that. Okay, the gloves have come out because it's getting a little bit hot to handle. Now, I've used our little deburr, and as you can see, we have penetrated sort of halfway through with the weld. So the idea now is to keep burring it out till you get rid of that little inclusion, so as you know it's 100%. So because obviously you're going to drill the hole back again, that's the only strength you've got is around there. But if you look from this side, you'll see how it is recessed. Now we can get in there. We can get in there with the deburrer and we can force the alloy in there for a good weld. What I'm going to do is just, before I fill that hole up, is just get that diameter off there. I might make a special tool for that, which is a ground down drill to do it, or I can ream it out close enough for it to do, because obviously it's not going to be, you know, a show pony motorcycle, but it'll do the job. So that's what we're going to do now. There, we'll fill that up and then we'll grind it from the other side so as we can get 100%. You can see how we've reamed it out so as we can get a good weld in there. It's looking quite good, so I'm not sure whether I'm going to fill the whole of it in, but we can work on it with the drill and the rotor, so there's not much to do on that, and that can be used. I'm pleased with that. It's gone quite, it's took all the inclusions out of it, so as I know it's like get on for 100%. So let's get it welded up and see where we go. Now there's a lot of welds gone in there, and what happens is you can get a lot of heat, and if you're not careful you could end up with a big molten pool of aluminium on your feet, because with aluminium you do not know, it will just go. And if you just see the edge there, it's got a little bit too hot, and it's slightly caused a concave. So what I need to do now is turn the power down, probably down to about 60 amps, and then we'll do a slow build all the way around the top to fill it in, That's the best thing with that. You can just keep filling it in but not get too much heat in it. Okay, so how did we do? Well, it's done. There's a slight little tiny little bit of an inclusion hole there, but that's probably because there's one stamped in the other side. We've just basically gone through it with a drill and just cleaned it up with a Dremel on the inside. That so his captive bolt will fit in there, and as you can see, it's about as good as it's going to get. So this is going to go on the motorcycle now, but there is another way of doing this if it does fail. I don't think it will. It depends if you're a bit of an animal and you jump on it, but there you go, saying that. But what I was saying is also, if you look at the distance between this one and that one, you could put a 2mm plate all the way around there and just put a little bit of a plug weld in the middle and weld it lovely all the way around the outside, and do the same on that one and then drill it through. That would then give it a lot more strength. Now that's done, sorted now, so that will go to a friend of mine. So the next challenge is my tube. So we know it's alloy, we know it's coated, and it's a horrible coating, and really you'd chuck them in the skip, wouldn't you, and just get a new one. But if I can help this guy out, I will. So what the aim is now, I'm going to clean this up with a sander and try and get it as best as I can, and I'm going to touch it with the TIG. Now I will say that when I did this, it got really hot, and I turned it down to around about 55 amps just to fill the craters in on there. But because we got it hot, we know the weld's penetrated in there, so as I am 99% sure that that's a good weld on that now, but time will tell. So as that now is forgotten about, hopefully. Let's have a look at this and see where we go from here. Now, my go-to tool is my sander, which I use an inox flap wheel disc. I use a lot of these, to be honest with you, and I find them quite good. Now also you can get it in the air type size, flat wheels and polishing discs and all sorts of stuff. They're a very good tool to go to. It's well recommended. So let's crack on with this then and see where we go. Right, I've just cleaned it around the edge. I'm going to try and keep the video running on this one. I don't want to bore people too much. We know the TIG's set on about 45 amps, and we're going to just touch it with that and see whether it obliterates it or not. I'm hoping I can get a little bit of attack on it. As soon as you can put the filler wire in the pool, it does cool it. So it's either going to obliterate it. Oh, I've just noticed that on the last bit of a weld I did, I actually dipped the tungsten. You don't want to be welding with that. That is highly contaminated. We're going to clean that off now. There are special grinders for tungstens, to be honest with you. I've never really bothered. I use the side of a fine stone on a pedestal grinder, and I find that quite decent enough for what I'm doing. I'm not doing x-ray stuff, not doing nuclear stuff. So let's get that ground up. As you can see, it's not ground to a point. There's no need to on using AC. This should ball over. It's always good to start on a bit of scrap first, just to get it in the ball state, and then we'll try it. So we'll have a go with that, shall we? So we'll put that back in there, hoping not to touch the trigger, because that is a trick of mine. And I'll just find any old piece of aluminium knocking about on the bench, and I'll just see if I can ball it over. Now that's quite thick, that is. That's about 6mm thick. It hasn't pulled it over yet because of the low amperage. But what I'm going to do now, I'm going to touch it on the tube and let's see what happens. It's either going to obliterate it or it will weld it. It's one of the others. I like to pre-press the button first as well, but I could use the pre-gas on there instead of the post, but it's just an habit of mine. Welder preference there again. Press the trigger first, gas comes out, press it again. Let's have a look. Right, that is highly contaminated, but we're going to try and drop a bit of wire on it. We've got it. We've got it. Not very good, but it will hold. Now if I can get 4 spots on this, this is all he'll need, and then what we'll have to do is just grind the excess of aluminium on the outside so he can get it on his machine. Let's have a go. Another one. Okay, not very pretty. 4 tacks on there. Let's have a look. Yeah, as you can see, quite ugly, but I'll clean those off, but it will hold it. So as that will keep the guy happy, I'm hoping. So as we can do the other side now, and all we do is we're just going to pop that in there like that. You can see all the contaminants round the top. The windscreen sealer, it's not good, but it will do the job, and he'll be happy with it, I'm sure. This one might weld a little bit better, but I doubt it. So there again, we're going to do 4 tacks again and just see if we can just drop a bit of alley on. It's got it, but it's not looking good. As I says, it will do the job. It's just a little bit of cleaning up to do now. Now that tube is quite hot, and I don't think I'll be able to hold that any longer. But what we're going to do now is we're going to clean it up, and I think that'll do him. We'll do the other one. We're going to do the other one a little bit different, and we're going to pull it down out the way this time. It's very hard to do, and then we're going to clean it up with our little, and this will show you the difference between contaminated and clean. So we'll give that a clean, see if we can razz it up on this. There will be any difference. Yes, there's still a lot of contaminant in it, but there's 4 welds on there, probably a lot better than the last stock, so we'll do the same on this and we'll clean it up and see how that goes. Well, thanks for watching. I hope this has been an interesting subject. So what we've done is we've repaired a motorcycle foot peg, which is not bad in all fairness. And the other thing, these tubes, it just shows that you can weld almost anything. I mean, the guy, that ain't going to move anymore. It's got 4 good tacks on it. That's all it needs. I've cleaned everything up so as he can actually get his gun, mastic gun, whatever he puts in here, his window screen sealant. It's cleaned up. It ain't going nowhere. He'll be happy with that. He'll be happy as Larry, to be quite honest with you. Now, please subscribe if you haven't already subscribed. There could be some real interesting stuff happening in the new year. Quite a few things happening, but I ain't going to give nothing away. Please subscribe, and all I can say is thank you for watching. Bye.